Okay, so let's do a brief synopsis of Lesson 3B. We've already talked about the PowerPoint. We've talked about some other examples. So let's talk about, let's just put a cap on Lesson 3B. We've already talked about the PowerPoint, and I'm just going to go over some notes on it just to kind of pull everything together. But example 1 says the total spending in the new federal budget is, this is for, right? This is, this would be your thousands, millions, billions, so trillions, $4,200 billion. So, and this is not the actual federal budget. It's just an example. So we want to change this into scientific notation. So we know to do that, we need the number in the front to be between 1 and 10. So I have to move my decimal to make this number between 1 and 10. So we're going to have 4.2 times 10, and we moved our decimal places 3, 6, 9, 12 places, so 4.2 times the 12th power, times 10 to the 12th power. Okay, so if we're looking at the scientific notation, so 4.2 is obviously a lot smaller than 4,200 billion. So if we're looking at the problem like that, we know that we have to use a positive exponent to move that number and make it bigger. So the diameter of a hydrogen nucleus is, I have no idea, I'm not even going to attempt to read that number, but we know that to make it in scientific notation, we have to write the number between 1 and, number in front has to be between 1 and 10. So I'm going to move that decimal all the way to the end. So we're going to have 1, and we've moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 places. And this time it's going to be a negative 15. So because 1 is a lot bigger than 0.00000, however many zeros that is, 1, right? So we've got to make it be a negative exponent, so it would move it backwards and make it smaller. Okay, 5.56 times 10 to the third. We want to write that in scientific notation. We can write it already is in scientific notation, sorry. We can write 556. And then, so right now we have 5.56 times 10 to the third. We want to move our decimal place 3 times in order to get it 1, 2, 3. So that's 5,560. So if I start out with 7.12 times 10 to the negative 2, remember that when you're dealing with a negative exponent, the directions are make it smaller. So we want to go backwards and move it 2 places. So we would have to add a 0 in front, so 0.0712. If I want to put this number in scientific notation, I have to make the number in front between between 1 and 10, so 3.45 times 10, and then we want to raise it to, we're going to have to move our decimal place 6 times in order for it to be between the 3 and the 4. Okay, and if we've got 7, we would have to move our decimal place 1, 2, 3, 4, 5 times, and we're making the number a lot smaller than 7, so it's going to be to the negative 5th power. Okay, and your calculator can do these mainly for you. I'm going to post a calculator video immediately after this. If you want to learn how to do this in your calculator, the TI-84, this will be a really good resource for you. I would definitely watch that video. So it kind of gives some examples about what happens on the calculator. So if you type in 3.5 times 10 to the 11th, now the way we could type it in with the rooftop, okay, there's another application that you can use to type the to type 10 raised to the power in the calculator. But this should work for our purposes. So if you type that in your calculator, you hit enter, you're probably not going to get this because it won't fit on your screen. So you probably will get this. And if you'll look, these two things are very similar. This E right here, right? So this just means 3.5, and then the E means times 10 raised to the 11th power. Okay, it's just another form of notation. So 2.1 times 10 to the negative fourth. If you type 2.1 times 10 rooftop negative, make sure you're using the negative and not the minus key. The negative is by the 0. Your calculator actually probably will give you this because this would fit on the screen. But you should also know that if you get 2.1 e to the negative 4, well, that just means 2.1 times 10 to the negative 4. That's what that e means. Okay? In our PowerPoint the other day, we talked about how big $1 billion is. But this is if we had to count $100 billion in $1 bills, how long would it take you in years? And assume that we can count every a bill a second. Okay, well, the first thing I'm going to have to do is figure out how many seconds are in a year if I want to know how many years it's going to take me. So I would start off with, well, I don't really know that, but I know there's 365 days in 1 year. Okay, and then the next fact I know is that there are 24 hours in 1 day. So we're trying to get these things to kind of cancel out. So we're trying to get to seconds in a year. It's the goal. And then I know that there are 60 minutes in 1 hour. That'll get my hours to cancel out. There's 60 seconds in 1 minute. That would get my minutes to cancel out. So on the bottom, all we're really left with is years, which is what we needed. And on the top, we've got 365 times 24 times 60 times 60 seconds. And that ends up being this is a 5. So 31,536,000 seconds in a year. Okay, well, in order for me to figure out how many years it's going to take, then I need to divide these things. So I need to take 100 billion. So 100 billion, we could write it like this. So this would be my 100,000s, millions, billions. So that's correct. That's the same thing as 1 times 10 to the 12th, right? Because we've got, nope, that's wrong. Sorry about that. So we've got 3, 6, 9, 10, 11. So this would represent $100 billion. It's easier to type this in the calculator than to try to type all those zeros, but it doesn't matter. Either way would work. Just make sure you check your work. So I'm going to take that number and I'm going to divide it by what we have. So I can count. There's 31,536 seconds in a year. So that's how many. So in 1 year, if I'm counting $1 a second, this is how many dollars I could count in 1 year. So to get my final answer, I need to divide those two. Okay, so 1 times 10 to the 11th divided by 31,536,000. I'm coming up with 3170.979198. So it looks like we couldn't do it in 3,170 years because we've got a decimal. So it would take us 3,171 years to count $100 billion if we're counting $1 in $1 bills if we're just counting 1 bill a second. That is crazy. Okay, so these, I want to point out to you that every single one of these problems will work out in your calculator if you just type them in just like that. But there are some tricks if you don't want to use your calculator. You could take 4 times 5, which is going to give me 20. And then when you multiply, as long as we have the same bases, you add the exponent. So you would do 3 plus 6, which would get us 10 to the 9th power. Now this is not in scientific notation. If we wanted it in scientific notation, the number in front would need to be between 1 and 10, at least 1 and up to 10, not greater than 10, sorry. So we would have to change that to the 10th. 2 times 10 to the 10th. Okay. Because we would have to move our decimal place over 1 to get it to where we need it to go. This is the exact same problem. Sorry about that. If we're doing division, we want to do the opposite. So 8 divided by 2 would give us 4, and then we would have times 10, and this time instead of, since it's division, instead of adding, we would subtract the exponent, so we would get 4 minus 3, which is to the 1st power. This is in scientific notation because this is at least 1, but smaller than 10. So your calculator would probably spit out 40 though, because that would definitely fit on the screen. And in this last problem, you can't really work this problem that way. So you would want to probably figure out what this is. Now you can type the whole thing in the calculator and it would calculate it for you. But I know that this is 700,000 because we've got 7 with 5 zeros. This is 3 million because we've got 3 with 10 zeros. So this should be 3,700,000. If we wanted to write that in scientific notation, 3.7 times 10 to the, we'd have to move it 6 times 6 power. Be sure to catch the video on how to use the scientific notation on the TI-84 calculator that's going to be under your course content.